Hello, everyone. Today we'll be looking into Chapter 2, Intro to Relational Model. Um, so this is just the outline of this Chapter 2. First, we'll talk about structure of relational databases. Then we'll talk about database schema. Then we'll talk about some keys and then schema diagrams. In our next lecture, we'll go over relational query languages and relational algebra. So this is a sample table. This is an example table for instructor relation. Any table, we call it a relation. Within this relation, we have columns or attributes, and we have tuples. So tuples are basically each of these item. For example, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tuples in this example. The tuple with ID 22222, what is the salary of that tuple? So that salary, this is the ID 22222, the salary is 95,000. So any rows is a single item. So we have all the details of that item or row, and we call it a tuple. And the attributes, these are columns. So these are different attributes. There are 4 attributes here: ID, name, department name, and salary. So attributes are stored as columns, and each single item with all the values is stored as tuples. And we call it tuples. So there are multiple tuples, and there are attributes. So A1, A2, AN are attributes. Here, in this example, ID, name, department name, and salary. These are attributes. So this is A1, this is A2, this is A3, and we can have multiple attributes. So dot, 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 AN. So this is basically this definition. A1, A2 to AN are attributes. And how do we define a relationship? A relation schema? We define a relation schema as R equals to A1, A2 until the AN attributes. So for example, within this table, the relationship is, or the relation schema is instructor equals to ID, name, department name, salary. This is what it's written here. Instructor equals to ID, name, department name, and salary. A relation instance R is defined over schema R, is denoted by R by R. What is a relation instance? So for example, the relation is the definition of the table. So relation of instructor is ID, name, department name, and salary. That is called the schema of that relation. But at any given time, for example, when this was recorded, we have this many tuples, and the last tuple we have is 98345, with name is Kim, department is electrical engineering, and salary is 80,000. This is the last entry that was given in this table. Now this is called an instance within this time. Now exactly at this time, this is the instance of this relation. In the future time, we can have more instructor in this table. So for example, 98346, and my name is Ward, and then department is computer science, and I have a salary that I have inputted here. So that is in the future, that is the instance of that future. When the table was created and only 3 of the instructor was added, within that instance, there were only 3 tuples. So right now, within this instance, there are this many tuples. So this is basically, we call the instance with small r, a relation instance R, that is small r, defined over the schema R, and is denoted by R of R, small letter R of capital letter R. The current values a relation are specified by a table. The current values a relation are specified by a table. An element T, T is basically tuple of relation R, is called a tuple and is represented by a row in the table. So this is nothing but, given this R of instance, a tuple is just a row defined within this table. So what are attributes? Attributes are the columns. These are attributes. For this table, ID, name, department name, salary, these are attributes. A set of allowed values for each attribute is called the domain of the attribute. For example, department name, the domain of this attribute is all the possible values a department name will hold. For example, University of Minnesota Crookston have computer science department, finance department, music department, physics, history, but we don't have medical science department, right? So medical science is not in this domain of the department name for the if the table is for University of Minnesota Crookston. But for example, University of Minnesota Twin Cities might have medical school. So within that university's instructor relation, department name can have medical science. So the domain will increase. Another thing is salary. For example, in salary, we define the salary is integer numbers. The domain is integer numbers. We cannot have some other values stored in salary. Name is all the possible names that a person can have, is the domain of that attributes. So attributes specifically have one domain. So it doesn't store, for example, in name, I won't store 001. So that cannot be one person names, right? So the domains are all the possible values that are characters, and that can be a name. The IDs are just numbers. We cannot store character strings. For example, I put an ID, let's say ABC XYZ. That is not possible because within this relation, we have defined the domain to be numbers. We can design in such a way that we can have characters as well, like ABC XYZ, but that can be another table. But within this table, the definition is this ID is integers. We are not storing any character values here. So the domain for ID here is integer values. Attribute values are normally required to be atomic, that is indivisible. That means if we look at these attributes, name, department name, so these are atomic values. We cannot divide them into more subcategories or subtables. For example, if I store in the department name, if I store computer science program, math science and technology department, finance program, or computer science program, computer science department name, but there are, for example, we have three more programs within computer science department. One is software engineering, one is information technology management, another one is cybersecurity. So we have three different programs within this department. So what if we store Srinivasam computer science, software engineering, computer science, and then, for example, ITM. So in the department, I'm storing two values, computer science and software engineering, finance, or computer science and ITM. So we are storing values that can be divisible. So we can have department name, and we can have another attribute called program, and we can store the program values over there. So that way we are not keeping multiple values within one attribute. So all the values of an attribute that needs to be atomic. We cannot combine different values to store in, or we should not combine different values to store in one attribute. That is the convention. A special value null is a member of every domain, indicated that the value is unknown. So we can store null, or we can have null in any of these attribute values. That means we don't know that value, that is unknown to us. So null is null is a member of every domain you can think of. Null values causes complications in the definition of many operations. So relationships relations are unordered. Order of tuples is irrelevant. Tuples may be stored in any arbitrary order. Example, instructor relation with unordered tuples. So here we have 222, and we have 7654, we have 101010. So these numbers, these are not ordered. These are unordered. So this is basically first come, first serve. If I store one more value, it will go at the bottom of this table. If I store another value, it will go at the bottom of that instance of the table. So I can have different this ranking or these values that we see here on the database table right now is basically unordered, and this will remain unordered. But there are ways we can see them in an ordered manner. There are queries that we can use based on ID. Give me a list of this table, or based on salary, ascending or descending order, give me the table values. Or we can say based on name, sort alphabetically, ascending or descending, we can see the values. So that is possible. But that is the view that we generate using queries. But in general, the tables are unordered. That means the relations are unordered. So database schema is the logical structure of the database, and database instance is a snapshot of the data in the database at a given instant in time. Example, the schema is just basically the relation that we defined. Instructor, ID, name, department name, and salary. It defines what the table holds, what kind of values the table holds. But instance is basically for that specific table at any given time, what are the values that that table is storing, or the table has for each attributes. That's basically the instance. So we are going to talk about keys. K is basically the super key, and this belongs to the relationship. Let K belongs to the relation. K is a super key of R if the values of K are sufficient to identify a unique tuple of each possible relation. So we need something that is uniquely identifying. For example, within this table, if I say I want to identify department name as the key, but we have computer science. If we say computer science, that points to 1, 2, and 3 tuples within this table. That means if I say computer science, I cannot uniquely identify one single tuple or one row. Okay, then let's do this. Let's make salary a key. If we do salary a key, right now we have, I think we have, okay, if we talk about 80,000, this will give us 2 tuples, right? With the same value. That means we cannot uniquely identify a single tuple or single row. The only thing that is unique, and if we say 1 2 1 2 1 2, this only indicates that who finance 90,000, this tuple, that means this ID, this is unique to this table instance. That means this is a candidate key. This is a possible key that we can use to identify single tuples within the table. But we have to define the constraints. For example, one constraint may exist that we do not repeat the ID. So if we have another row that wants try to enter that with ID 10101, it will give us an error that the ID already exists. Please use some different ID, and we cannot add that value or that tuple into this table. So we need keys that are unique and that can identify a single tuple. So K is a super key of R if the values of K are sufficient to identify a unique tuple of each possible relation R. Example, ID and ID name are both super keys of instructor. So instead of ID, we can have ID and name concatenated, or a combination of these two values. This can be super keys. So name, right now, there are no repeating names, but this can be a possible scenario where Kim, a different person named Kim, comes in and she teaches, for example, computer science or history. Then we will have Kim. We cannot by default, we cannot use name as an attribute, that can be a key. So we have to have it unique. So Kim with ID 98345, and that is unique. But Kim with another ID that is 98 or 76545, that is unique, and that is not common between each other. So we can use ID and name as a combination for the super key, or we can use the ID itself as a super key. One of the candidates is selected to be the primary key. So for there can be, for example, multiple candidates that can be a primary key. For example, I mentioned ID itself can be a candidate key. Candidate key is basically the keys that are unique, and we can use them as the primary key. So ID can be a primary candidate for the primary key. ID with combining the name, that's also unique. That can be a candidate key. If we store social security numbers within this table, or the last 4 digits of social security numbers, that can also be a candidate key. So we have to choose one that is our primary key within this table. Which one do we select as our primary key? One key aspect is whatever the primary key that we select, that can be a foreign key for another table. What is foreign key? Foreign key is basically values in one relation that must appear in another relation. So for example, department name, this is a foreign key for our instructor table. That is, department name can be a unique primary key for another table that is called department table. And within that table, we can store values. For example, where is this department building hosted? What is the budget of this department? So physics department has a unique building number and budget number. So physics department, physics is unique in that table and it is not repeated again. Then we have computer science, electrical engineering. We define where these departments are hosted in terms of which building, and then what are their budgets, all that information. So that for that table, the department name will be the primary key. But here, instructor table, if we say, hey, Einstein works in which building, we cannot get that information from here. So we know Einstein works in physics department. So physics department is my foreign key for another table that is department table. And through that, we can find out, okay, in that table, if the primary key is physics, where is physics being hosted, like which building? And then we can find out that way, yes, Einstein is working in that building. So there are referencing relation and referenced relation. In this example, instructor is referencing to the department table, and department table is being referred by the instructor table. So that is referenced relation and referencing relation. Example is department name in instructor is a foreign key for instructor referencing department table. So this is an example of a university database. Just quickly look through it, pause the video, and see how this table is designed. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tables in this database. There are tables for the department where department name is the primary key, which building this department is hosted, and the budget. And then department name is a foreign key for the course table. So a course is being offered, but from which department, that department name is a foreign key. In the course table, primary key for this course table is course ID. What is the course title? That is the name of the course, and then how much credits is that course? These are values. Course ID is the primary key, but department name is the foreign key for department table. Department table primary key department name is also referred by some other tables. For example, instructor has department name, so that is for instructor table, department name is the foreign key, and then it refers to the department and where we have the department name as the primary key. So foreign key is referencing to some places primary key, some other tables primary key. Just quickly look over this, and if you have any questions, just send me an email. If you are having confusions, you can also schedule one-on-one Zoom sessions with me. Just email me and we will figure out a time that we can sit together and answer your queries. Thank you.